something entered our skies that wasn't born here. At first, it looked like nothing more than a faint spark of light, barely noticeable against the endless stars. But as telescopes followed its path, the strangeness began to unfold. Its orbit didn't circle our sun. It cut through, hyperbolic, as if it were only passing by. Its chemistry didn't match what we know, and its silence felt almost intentional. Was this truly just a comet of ice and dust, or could it have been something else entirely, something wrapped in the most perfect disguise the universe could offer? These are the mysteries we'll be exploring tonight, the questions that live in the grey space between science and suspicion, where fact and imagination are impossible to untangle. As you listen, allow yourself to drift, to wonder what secrets lie hidden in the stars above us, and to think about how little we really know about what moves out there just beyond our reach. Before we begin, I'd love to invite you to be part of this community. If you enjoy these mysteries, remember to subscribe and give this video a like. It helps us reach more curious minds. And take a moment to leave a comment. Tell us where in the world you are right now, what time it is for you, and if you'd like, share what part of tonight's mystery you find the most exciting. It's always incredible to see just how many of us are watching together under the same sky. The masked arrival, how 3I Atlas first appeared as just another faint speck before suspicion grew. It began as so many cosmic stories do, not with a bang or a flash of light, but with a faint, almost forgettable glimmer in the night sky. 3I Atlas did not storm into our awareness like a fireball tearing across the horizon. It appeared as a speck, one among countless others, that most eyes would never notice. For the astronomers watching the sky through robotic surveys and automated telescopes, it was first just another data point, another moving blur against the tapestry of stars. To understand how this looked, imagine standing on a beach at night. The waves stretch endlessly, and scattered across the shoreline are grains of sand glinting under the moonlight. Every so often, one grain shifts, catching the eye differently, seeming almost alive. This was 3I Atlas, a grain of sand that moved where no grain should have, a glimmer that refused to stay still. At first, nothing about it screamed extraordinary. The sky is full of such wanderers, asteroids, comets, icy fragments that circle the sun in long looping orbits. Telescopes catalogue them constantly, adding line after line to the great ledger of near-Earth objects. But then came the details that didn't fit. Its trajectory was unusual. Its brightness shifted in ways that puzzled. Slowly, suspicion began to grow. This was not one of ours. The first whispers among astronomers must have carried both excitement and hesitation. After all, this had happened before. In 2017, the discovery of Oumuamua had shocked the world, an interstellar visitor unlike anything we had ever seen. And only 2 years later, Borisov followed, a comet blazing with alien ice. By the time 3I Atlas appeared, the possibility was no longer unthinkable. And yet, it was still staggering, another traveller from beyond the sun, hiding at first behind the mask of a faint speck. The word masked feels fitting, for in a sense, that is what 3I Atlas was, disguised by its ordinariness. It looked like a comet, acted like a comet, at least on the surface. But what better disguise could there be for something alien, for something intentional, than to appear as the most natural thing in the universe? If one wanted to slip unnoticed into another system, to drift past its inhabitants without stirring alarm, what form could be safer than that of an icy wanderer, indistinguishable from millions of others? This, of course, is where imagination begins to stir, for if 3I Atlas were merely ice and dust, it was still extraordinary, an emissary from a star we may never know, carrying chemistry older than Earth. But if it were more, If it were cloaked in cometary disguise, then its faint first appearance takes on a different meaning. Not a chance encounter, but a carefully hidden arrival. Like a ship approaching under fog, lanterns dimmed, sails muted, hoping to pass unnoticed. And yet, even under the mask, it was noticed. Humanity's telescopes are sharper now than they have ever been. Automated surveys sweep the heavens like searchlights, logging everything that moves, even those faint glimmers. It was inevitable that someone would spot the shift, the faint trace of light that didn't belong. But this too invites a question. Was it inevitable to us, or expected by it? If Three-Eye Atlas were more than natural, did it want to be seen, just enough to spark our curiosity, but not enough to reveal its truth? When scientists confirmed its hyperbolic orbit, proof it was not bound to the sun, the sense of wonder grew. Here was an object that had travelled for untold eons, slipping silently into our neighbourhood before continuing on its way. And yet, the timing felt uncanny. Why now? Why in the brief window of human history when we have the technology to notice? For billions of years, Earth has circled the sun, unknowing. For billions more, countless wanderers must have passed unnoticed. And then, in the span of a few decades, three of them, Oumuamua, Borisov, and now Three-Eye Atlas, appear in quick succession. Some would say this is coincidence, that the galaxy is vast, and so are the numbers of comets it sends drifting. Others would say it is not coincidence at all, that like masked actors stepping onto a stage, these visitors appear when the audience is finally ready to watch, ready not just to see, but to wonder. Three-Eye Atlas, then, was never just a faint speck. It was the reminder that faint specks can change everything, that hidden within the ordinary may lie the extraordinary. It wore its mask well, shimmering like any other comet, tracing a path like countless others. But suspicion grew because masks always slip, even just a little. Its chemistry was odd. Its brightness shifted strangely. Its timing was suspicious. Like the first notes of a song carried faintly on the wind, its arrival stirred questions we are still asking. Was it just ice and dust, flung from a distant star by chance, or was it a disguise, perfect in its simplicity, meant to test how closely we were watching? The truth, for now, remains hidden in that faint first glimmer, the masked arrival that passed almost unnoticed until it didn't. Not from our sun. Why its hyperbolic path proves it was born in another system. When astronomers tracked the faint light of Three-Eye Atlas and mapped its orbit, one detail leapt out with unmistakable clarity. It was following a hyperbolic trajectory. That phrase may sound like an abstract piece of mathematics, something hidden in textbooks or chalkboard equations, but in truth it is one of the simplest and most profound clues we have. A hyperbolic orbit is the signature of an outsider, proof that this object was not born here and will never return. To understand why this matters, it helps to picture the solar system not as a void, but as a kind of celestial racetrack. Most comets and asteroids follow predictable lanes, ellipses. Some have short ovals, circling back every few years. Others stretch into long, thin loops, taking thousands of years to return. But all are bound, tugged again and again by the sun's gravity, like runners forever tied to the track. Three-Eye Atlas does not run these lanes. Its orbit is hyperbolic, open, untethered, the path of a traveller who enters the stadium only once and keeps running straight out the far gate, never to return. Gravity tried to bend it. The sun pulled as hard as it could, but the comet's speed was too great. It came in from the cold, looped briefly around our star, and is now gone, its path carrying it back into the darkness. This single fact, its hyperbolic orbit, tells us something staggering. It was born in another star system, its ices condensed in alien conditions under a light not our own. It may have formed in the protoplanetary disk of some long-forgotten sun, been hurled outward by giant planets, and cast adrift through interstellar space for billions of years before, by cosmic chance, crossing our small patch of sky. And this leads us to wonder, what shores did it once circle before it was exiled? Did it brush past worlds that no longer exist, planets shattered or swallowed by their stars? Did it share space with civilizations we will never know, crossing their skies as it once crossed ours? When we say not from our sun, we are really saying this thing is a fragment of somewhere else entirely. It is as though a shell washed up on our beach, not from any ocean we know, but from a sea on the other side of the world. Hyperbolic paths are rare. Almost all comets are captured by the sun's gravity and remain bound to it, no matter how stretched their orbits. Only a few objects break this rule, and when they do, they come with stories far older than we can imagine. Oumuamua in 2017 was the first, a thin, tumbling shard that defied classification. Then came Borisov in 2019, blazing like a more ordinary comet, but with chemistry not quite like ours. 3I Atlas followed, carrying its own oddities. Each one traced a hyperbolic arc, each one announcing, "I am not from here." But there is more to the mystery. For some, the hyperbolic orbit is not just a signature of origin, but a potential disguise. If one wished to send probes across the galaxy, what better way than to hurl them outward on hyperbolic paths, hidden among the natural debris? They would arrive not on circular orbits like artificial satellites, not on repeating ellipses, but on single-use arcs, slipping by once, silent and swift, leaving no time for interception. Nature gives us this pattern, but so might intention. The question then lingers. Was 3I Atlas flung outward by the chaotic birth of its home system, just another shard among countless others? Or was it more than chance, riding a hyperbolic arc by design, aimed to drift into alien skies unnoticed? We may never know the answer. What we do know is this: hyperbolic orbits are the footprints of strangers. They do not belong to the sun, they do not circle back, they do not linger. They arrive suddenly, stay briefly, and vanish forever. And each one leaves behind the haunting certainty that the galaxy is full of wanderers, each carrying the mark of somewhere else, each whispering, "Not from your sun." The speed of secrets, its astonishing velocity, and how that speed makes it nearly untouchable. When astronomers first began to calculate the path of 3I Atlas, one number stood out with quiet astonishment: its speed. It wasn't merely fast by everyday standards, it was fast by cosmic standards. Faster than any spacecraft humanity has ever launched. Faster even than most comets bound to our sun. It came racing in like a stone slung by the hand of the galaxy itself, and before we could catch our breath, it was already on its way out. To put that into perspective, imagine a bullet fired across a stadium. A human eye barely has time to follow it before it strikes the far wall. Now stretch that metaphor into space. 3I Atlas was that bullet, crossing our solar system with such velocity that even the sun's gravity couldn't pin it down. Its hyperbolic orbit wasn't just proof of its interstellar origin. It was the natural consequence of speed beyond capture. Scientists estimate that when it passed through, 3I Atlas was moving at tens of kilometers per second, enough to cross the entire width of the United States in less than a minute. By the time telescopes had confirmed its presence, its trajectory had already carried it past its closest approach. Like a train roaring past a station at full throttle, it did not slow, it did not stop, it did not wait for us. And this speed raises questions. What force could fling such an object to such velocity? The most accepted answer is gravity, the tug of giant planets in its birth system, slingshotting it into the void. Much as Jupiter's gravity can fling comets out of our solar system, so too might a distant gas giant have hurled 3I Atlas away billions of years ago, setting it adrift through the galaxy. Over time, it accumulated neither rest nor anchor, only speed, carrying it ever onward. But other possibilities are more unsettling. If one wished to send probes across interstellar distances, speed would be both a blessing and a curse. A fast probe is harder to intercept, harder to detect for long, and less likely to be trapped by a star's pull. It arrives suddenly, departs quickly, and resists close study. Could 3I Atlas's speed be more than chance? Could it be a design feature, the signature of something built to slip through unnoticed? To imagine this is to recognize how helpless we are before such velocity. Humanity's fastest probe, Voyager 1, drifts outward at about 17 kilometers per second, and it has taken nearly half a century to travel just a fraction of the distance 3I Atlas crossed in a relative blink. Even our most ambitious rockets could never have caught it. Once it was spotted, it was already too late. Gone before we could even dream of sending a chase. Its speed made it untouchable, a visitor glimpsed only in passing, its secrets intact. There's something almost theatrical about it. 3I Atlas entered stage left, delivered no lines, and exited stage right before anyone could stop it. We, the audience, were left staring into the dark, wondering what the performance had meant. Its speed was both its mask and its escape, allowing it to slip past scrutiny with barely a trace. This too mirrors life in familiar ways. Think of how fleeting moments often carry the deepest mysteries. A stranger glimpsed in passing, a shooting star streaking across the night, a dream half remembered upon waking. The very brevity, the speed of the moment makes it harder to understand, but more haunting to remember. 3I Atlas was that fleeting mystery on a cosmic scale, rushing by, just out of reach, leaving us with more questions than answers. And there is a lesson here. Our technology, impressive though it seems, is not yet suited to the tempo of the galaxy. We crawl where the stars race. We linger where interstellar wanderers streak past. If 3I Atlas held secrets, whether of chemistry, of ancient systems, or of something more intentional, we were powerless to uncover them, simply because it moved faster than we could follow. Its speed was a barrier, but also a message, a reminder that the universe operates on scales and rhythms we cannot yet match. 3I Atlas carried its secrets away with it, wrapped in velocity, untouchable by even our most ambitious reach, and in its passing we were left with the realization that sometimes the greatest mysteries are not the ones hidden in darkness, but the ones that move too fast for us to hold on to. Chemistry that shouldn't be, Webb's findings of CO2 dominance, unlike any comet we know. When astronomers turned the James Webb Space Telescope toward 3I Atlas, they expected the familiar. Comets, after all, are not strangers to us. We've studied them for centuries, watched them flare with icy tails, and even sent spacecraft to chase and land on them. Their chemistry, though varied, follows a kind of cosmic recipe. Water ice as the main ingredient, dust as the crust, and smaller traces of carbon monoxide, methane, and carbon dioxide to season the mix. That recipe has held true across countless comets born under our sun, but 3I Atlas broke the rules. Instead of water dominating its outgassing, Webb's instruments detected something startling. Carbon dioxide was the major driver of its activity. In other words, its frozen heart was not breathing steam as our comets do, but clouds of CO2, an alien breath, a chemistry that shouldn't be. To grasp how strange this is, imagine baking bread 1,000 times, always with flour, water, and yeast. Suddenly, someone hands you a loaf made entirely of something else, yet insists it is still bread. You recognize the shape, you see the crust, but the substance is all wrong. That was the puzzle of 3I Atlas. It looked like a comet, behaved like a comet, but at its core, it spoke a different chemical language. The dominance of CO2 suggests that 3I Atlas formed in conditions unlike anything in our solar system. Perhaps it was born farther from its parent star than most comets here, in regions so cold that carbon dioxide, not water, became the main ice. Or perhaps its home system had a very different balance of elements, a cosmic kitchen that produced flavors unfamiliar to us. Either way, it was a fragment of another star's story, carrying in its chemistry the fingerprints of alien origins. But science is only one lens through which to view it. The conspiratorial mind sees something else, disguise. What if the chemistry was too strange, too deliberate, almost like camouflage? A comet that exhaled unusual gases might confuse us, distract us, make us question whether we are looking at something natural or something engineered. And if one wished to send a disguised machine, wouldn't cloaking it in a body of strange ice be the perfect cover? A mask of chemistry, hiding technology within. Of course, scientists lean toward natural explanations, but even they admit that Webb's findings were a surprise, a challenge to existing models of comet formation. The fact that 3I Atlas was so unlike the comets we know forces us to confront how little we understand about the diversity of planetary systems across the galaxy. If every star forges its own unique recipe, then each interstellar visitor will bring a new taste, a new puzzle, a new chemistry that reshapes what we thought we knew. And this reshaping is vital, because 3I Atlas, in being chemically wrong, teaches us that our solar system is not the blueprint for all others. It is only one version. For decades, humans assumed that other systems must look like ours, with planets aligned in neat rows, comets carrying mostly water, and life requiring Earth-like balance. But then the exoplanets came, and we found worlds stranger than fiction. Hot Jupiters hugging their stars, frozen giants adrift in darkness, rocky planets with atmospheres of lava. And now, with interstellar comets, we see the same diversity reflected in small bodies too. The question becomes not why is 3I Atlas different, but why did we ever think it would be the same? Still, the mystery lingers. Its alien breath, those jets of CO2, felt like a whisper from somewhere else, a reminder that we are not the center, not the template. And in that whisper, people hear different things. Scientists hear data, conspiracists hear intent, dreamers hear possibility. Whatever the truth, Webb's discovery left us with a haunting image, a comet from beyond, exhaling not steam, but carbon dioxide, as though its frozen lungs had been shaped in a different universe altogether. Its chemistry shouldn't be, and yet it is. It is real, it was measured, and it slipped past us carrying its secret balance intact. And so 3I Atlas drifts on, leaving us with more questions than answers. What other chemistries are out there waiting to cross our skies? How many more rules of our solar system will be broken when the next visitor arrives? Its alien breath may already be fading, but the shock of it remains, a reminder that even a faint glimmer can overturn everything we thought was normal. Hidden in plain sight. Why an interstellar probe would mimic a comet's natural form. If you were an advanced civilization planning to send machines across the galaxy, how would you hide them? Space is vast and dark, but it is also full of natural wanderers, asteroids, comets, icy fragments flung outward from newborn solar systems. Among these countless fragments, a probe could travel unnoticed for eons, disguised in a form so ordinary that no one would think twice. And that disguise would be perfect, the comet. 3I Atlas showed us why. On the surface, it looked like just another comet. It flared near the sun, developed a faint tail, and drifted on a predictable path. Nothing about its first appearance screamed artificial. To most, it was only another line of data in the endless catalogue of icy wanderers. But therein lies the brilliance of the disguise. Because in a universe filled with comets, who would suspect one of being something more? Comets are nature's camouflage. They are irregular, dusty, and unpredictable. They flare and fade, sometimes suddenly breaking apart. Their surfaces are blackened, their cores hidden under layers of ice. To cloak a machine in such a body would be like hiding a watch inside a snowball. Who would ever break it open to look? And even if they did, how could they tell where the natural ended and the artificial began? The chemistry of 3I Atlas only deepens the intrigue. Webb's instruments revealed that its outgassing was dominated not by water, but by carbon dioxide, a composition unlike most comets we know. Scientists framed this as a mystery of formation, perhaps evidence of an alien star system with colder, stranger conditions. But a conspiratorial mind might ask, was that chemistry part of the disguise? A way to seem natural while still ensuring a pattern that confused and distracted? Imagine the cleverness of such a plan. A probe travelling as a comet would not need to evade detection. It would be expected. It would blend in with the millions of icy fragments astronomers anticipate. Only when studied closely would small oddities emerge: strange brightness shifts, unexpected chemistry, unusual timing. Oddities that might be dismissed as quirks of nature. In plain sight, the disguise would hold. And history shows us how often nature and intent blur. Oumuamua, the first interstellar visitor ever detected, sparked debates that still rage today. Was its strange, tumbling motion natural, or was it a light sail catching the faint winds of starlight? Was its lack of a visible tail evidence of something artificial? Scientists leaned toward natural explanations, but even they admitted discomfort. 3I Atlas, arriving not long after, seemed more comet-like, more normal. But maybe that is the point. Perhaps Oumuamua was the test, the strange cousin that stirred debate, and 3I Atlas was the refinement, the perfect disguise. If this feels far-fetched, consider how humans themselves already hide technology in plain sight. Military drones are painted to blend with clouds. Submarines mask their noise to sound like ocean currents. Even on Earth, deception thrives in imitation. Nature itself does this too. The moth that mimics the bark of a tree, the fish that looks like coral, the predator that waits disguised as part of the landscape. Why wouldn't a civilization capable of crossing stars adopt the same trick, hiding machines inside the forms the universe already provides? And this disguise has another advantage: time. Comets are expected to survive for billions of years, drifting endlessly between stars. A disguised probe could do the same, lasting longer than civilizations, longer than the stars themselves. To us, it would be nothing more than an icy relic. To those who built it, it would be a courier, a watcher, or a seed, camouflaged against the suspicion of those who might find it. Of course, there are simpler explanations. 3I Atlas may truly be nothing more than ice and dust, a wanderer born in the cold cradle of another star system. Its oddities may be natural quirks, the way every snowflake is unique. But the idea of disguise lingers because it is so plausible. If we were to send probes across the galaxy, we might do the same. We might hide them in cometary shells, send them drifting along hyperbolic paths, and let them masquerade as natural debris. 3I Atlas reminded us how easily such a disguise could work. A faint speck of light, dismissed as ordinary, revealed itself to be extraordinary only when studied closely. And even then, questions remain unanswered. Was it simply a comet? Or was it something else, something hidden in plain sight, passing through under a mask so perfect that even our most powerful instruments could not see beyond it? It left quickly, as all interstellar visitors do. but its passing left behind a lingering suspicion, a quiet reminder that in a universe filled with masks, sometimes the most ordinary forms may be the ones hiding the greatest secrets. The Vanishing Act, how 3i Atlas slipped behind the sun just as interest peaked. 3i Atlas did not blaze across the heavens like a comet in a children's storybook. It did not hang overhead for months, a glowing arrow that anyone could see. Its story was shorter, stranger, and perhaps more frustrating. For just as curiosity about it was reaching its height, just as scientists began to focus their telescopes with sharper intent, 3i Atlas disappeared, slipping behind the glare of the sun, hiding in plain sight, unreachable. To understand this, picture a stage where the curtain falls not at the end of the performance, but halfway through the first act. The audience is leaning forward, hungry for more, when suddenly the lights go out and the actors vanish. That is what happened in 2024. Humanity, just beginning to realize that 3i Atlas was no ordinary comet, lost its chance to watch. The sun itself became the curtain, drowning the faint speck in light, too fierce for even our best instruments to penetrate. This vanishing is, in one sense, ordinary. The orbits of comets often carry them close to the sun, where its overwhelming brilliance blinds our telescopes. Astronomers call it a solar conjunction, a time when Earth and its instruments are simply in the wrong position to see. Spacecraft sent to Mars face the same blackout periods when the sun moves between us and them. From a technical standpoint, the disappearance of 3i Atlas was expected, but from a human standpoint, it felt almost staged, because timing matters. 3i Atlas was showing its most intriguing behaviors when it slipped behind the sun. Its chemistry had shocked scientists, carbon dioxide dominating instead of water, an alien recipe no comet here had ever matched. Its faint tail flickered strangely, as if it were more than just dust and gas. Suspicion, both scientific and conspiratorial, was growing, and then, at that exact moment, it was gone, swallowed by the sun's glare. For conspiracy theorists, this was fuel for fire. They asked, was this coincidence or design? What if the comet wanted to vanish? What if the very orbit that brought it here had been chosen to ensure that our glimpse would be brief, our questions unanswered? In the language of the dark forest hypothesis, this might be exactly what a scout would do, reveal just enough to be noticed, then vanish before closer inspection, leaving only whispers behind. Even for scientists, the frustration was real. Observatories worldwide had trained their instruments on the visitor, building collaborative campaigns to measure its light, track its dust, and capture its chemistry. The James Webb Space Telescope itself had turned its gaze toward the comet, providing data that astonished and unsettled. And then, just when more answers seemed within reach, the sun forced them to stop. Like detectives losing their witness mid-sentence, astronomers could only wait and hope it would reappear. And when it did, 3i Atlas had grown fainter. Its moment of peak activity had passed. Its secrets were slipping away. This is not the first time such a thing has happened. Oumuamua 2 was recognized too late, studied only after it had passed closest to Earth and was already fading. Borisov burned brighter, but raced away faster than probes could follow. And now, 3i Atlas vanished, right when attention was at its highest. One after another, these interstellar visitors arrive with the same frustrating rhythm, too brief, too fast, too hidden, as if nature or something else wanted them to be noticed but never truly known. There is an odd poetry in this. The sun, giver of life, became the thief of vision. Its brilliance blinded us, not out of malice, but simply because of geometry and physics. And yet, from the perspective of myth, it almost feels deliberate. The stranger came, offered a glimpse of its alien breath, and then stepped into the spotlight so bright that no eye could follow. For the dreamers among us, this vanishing act stirs imagination. What if the comet was more than comet? What if it was designed to arrive at just the right angle to pass behind the sun, a cosmic sleight of hand? What if it wanted to slip into shadow, as if whispering, "You may see me, but only on my terms"? Whatever the truth, the vanishing of 3I Atlas left us with something more potent than data: anticipation. Because when something disappears just as you lean closer, you lean further still. The unanswered becomes more compelling than the answered. The mystery grows heavier than the facts. 3I Atlas may have hidden behind the sun, but in doing so, it ensured that its story would endure. And so, its vanishing act was not the end of its presence in our imagination, it was the deepening of it. A faint speck became a stranger with secrets. A comet became, perhaps, the perfect disguise. And even after it emerged again, fainter and farther away, the shadow of its disappearance lingered, like a magician who never reveals the trick. Dust that whispers. Could its strange outgassing patterns hide encoded structures? Every comet breathes when it nears the sun. The warmth awakens its frozen heart, and jets of gas burst outward, carrying with them dust that drifts into a glowing tail. For most comets, this is a predictable performance: water vapor mixed with carbon monoxide, a stream of particles spreading out like smoke from a campfire. But with 3I Atlas, the performance looked different. Its tail did not simply brighten and fade, it flickered. Its plume seemed uneven, almost patterned, as if the dust itself were speaking in a language we could not yet understand. This is not to say scientists saw a message written across the sky, but they did note irregularities, bursts of carbon dioxide when water should have dominated, sudden shifts in brightness that didn't match what standard models predicted, and trails that looked more like broken phrases than steady flows. For astronomers, these were puzzles to be solved with chemistry and physics. For others, they sparked a wilder thought. What if the dust was not just dust? Imagine a message hidden not in letters or symbols, but in rhythm. Like a lighthouse flashing across a dark sea, the flicker of 3I Atlas could be seen as a kind of signal: brighten, dim, flare, fade, patterns repeating in ways that our instruments might record but not yet interpret. If you were an advanced civilization sending probes across the galaxy, would you not hide your messages in the most natural phenomenon of all? Dust trails that look like ordinary cometary outgassing, but that carry structures too precise to be coincidence. It would not be the first time humans mistook a natural rhythm for communication. In the 1960s, when radio astronomers first detected pulsars, distant stars sending out bursts of radio waves at exact intervals, some believed they had found alien beacons. The signals were so precise that the first was nicknamed LGM-1, Little Green Men. Later, of course, science revealed pulsars to be rapidly spinning neutron stars. But the lesson remained. The cosmos often speaks in rhythms that can feel deliberate, even when they are not. With 3I Atlas, the reverse question arises: what if the deliberate hides within what we assume is natural? Consider how we already encode information in patterns of particles. A simple example is smoke signals, plumes rising into the air, broken into bursts that carry meaning. Or think of Morse code, dots and dashes hidden in pulses of sound or light. To us, they are unmistakable. But to an outsider who doesn't know the code, they might look like nothing more than random noise. Could 3I Atlas be doing something similar? Outgassing that, to our untrained eyes, looks chaotic, but to someone who knows the pattern, reveals intent. And even without intent, the dust may still whisper truths. Every particle carries within it the chemistry of its birthplace, frozen in time since the comet's formation. Studying that dust is like reading fragments of a lost book, chapters written around another star, scattered across our sky. The unusual dominance of carbon dioxide in 3I Atlas's plume is itself a kind of code, telling us that it formed in colder, more alien conditions than anything in our solar system. In that sense, the dust does not need to be artificial to carry a message. It already speaks, just in the language of chemistry and physics rather than words. But the thought lingers. What if both are true? What if natural chemistry hides artificial structure, like ink spilled across a page where faint letters still show through? If 3I Atlas were a probe, or contained something more than ice, then its outgassing could be the camouflage and the signal at once, a mask of natural behavior with hints of deliberate design embedded within. Some conspiratorial thinkers even suggest we are failing to recognize the obvious, that our telescopes, focused on brightness and spectra, are blind to the deeper shapes hidden in the dust. That if we mapped the trails in 3 dimensions, if we studied not just the chemistry but the geometry, we might see lines too straight, clusters too regular, patterns that should not be. Perhaps the message has already been written across our skies, but our eyes are not yet sharp enough to read it. This is the haunting allure of 3I Atlas. It looked like a comet, and in many ways behaved like one. But in its uneven plume, its strange flickers, and its alien breath, it also suggested something more. Whether by chance or by design, the dust seemed to whisper. Not loudly, not clearly, but in the faintest tones of mystery. And maybe that is the point. Not every message is meant to be understood. Some are meant only to remind us that there is something out there beyond our reach, moving through our skies with secrets intact. 3I Atlas may have carried nothing more than frozen gas and shattered ice. Or it may have carried something else, hidden in its tail, disguised as dust, but whispering all the same. Echoes of Oumuamua, why scientists compared it to the first interstellar visitor. When 3I Atlas first drew attention in 2024, many astronomers felt a familiar chill of recognition. This was not the first time Earth had glimpsed something that didn't belong, something racing through the solar system on a path that defied capture. 7 years earlier, in 2017, another stranger had arrived, one that shocked the scientific world and still fuels debates today. Its name was Oumuamua, a Hawaiian word meaning scout or messenger. To understand why 3I Atlas was immediately compared to Oumuamua, we have to recall the strangeness of that first visitor. Oumuamua was unlike any comet or asteroid we had ever seen. Its orbit was hyperbolic, proving it came from beyond our sun. Its speed was immense, as though it had been flung outward by the hand of another star. But it was its shape and behavior that unsettled scientists most. Unlike comets, it showed no bright tail of dust or gas. It tumbled oddly, flashing brighter and dimmer in ways that suggested it might be cigar-shaped or perhaps pancake-flat. Its surface reflected sunlight strangely, and its acceleration as it left the solar system did not match what gravity alone could explain. Some said it was outgassing in ways too subtle to see. Others whispered, what if it was artificial? When 3I Atlas was discovered, echoes of that earlier mystery immediately returned. Here again was an interstellar object following a hyperbolic arc, racing through space at speeds no Earth-made probe could hope to match. It, too, carried anomalies. Its chemistry was unlike anything we expected, dominated not by water but by carbon dioxide. Its tail flickered strangely, as though pulsing with hidden rhythms, and just as interest peaked, it slipped behind the sun, vanishing from sight at the very moment when answers seemed closest. The comparison was irresistible. Oumuamua had left us baffled, an unsolved riddle. Borisov, the comet that followed in 2019, felt more ordinary, alien in chemistry, yes, but undeniably comet-like. 3I Atlas fell somewhere between, with the cometary appearance of Borisov, but the unsettling oddities that recalled Oumuamua's enigma. It was as if the galaxy had sent another messenger, this time wearing a better disguise. Scientists, cautious as ever, stressed the differences. Unlike Oumuamua, 3i Atlas did produce a visible tail, proving it was shedding material like a comet. It was less elongated, less geometrically strange. But the echoes remained, particularly in the way both objects resisted easy explanation. Oumuamua's light curve didn't fit simple models. 3i Atlas's chemistry didn't fit familiar recipes. Each, in its own way, bent the rules. And beyond the science, the comparison stirred deeper unease. Oumuamua had arrived first, like a scout, and then left without a word. 3i Atlas followed, another visitor, different but equally mysterious. Was this a coincidence of discovery? Our telescopes finally sharp enough to notice wanderers that had always passed by? Or was it a sequence, a pattern, a reminder that these objects do not arrive alone? Imagine hearing a knock on your door one evening. You open it, and there is no one there, only a faint footprint on the step. Days later, there is another knock, this time with a shadow glimpsed in the corner of your eye. You never see who it is, but the repetition tells you someone is calling. That is how 3i Atlas felt in the wake of Oumuamua. Two messengers, different but related, their very arrival suggesting that the universe is less quiet than we once believed. The echoes extend into public imagination too. Oumuamua inspired theories of alien probes, disguised sails, and interstellar messengers. 3i Atlas, with its odd chemistry and convenient vanishing act, slipped into the same current of speculation. Both became canvases for our questions about life beyond Earth, about watchers in the dark, about whether we are truly alone. And perhaps that is why scientists compared them so quickly. Not because they were identical, but because together they form a story of strangeness arriving at our doorstep, a story that may continue, each visitor an echo of the last, each raising the same unsettling question: are we observing them, or are they observing us? Oumuamua left without answers. 3i Atlas did the same, but the comparison between them lingers like a resonance, a low hum in the background of our thoughts. Two messengers, two mysteries, two reminders that the galaxy is filled with echoes we cannot yet interpret. And in those echoes, we hear the possibility that the perfect disguise has already passed through our skies, perhaps more than once. The silence of signals. Why no radio emissions were detected, and why that may be intentional. When 3i Atlas swept through our solar system, astronomers turned not only their telescopes toward it, but also their antennas. Across the world, dishes designed for radio astronomy, giant ears listening to the sky, were tuned to see if the visitor might be speaking. If it was more than just a comet, perhaps it would hum with radio transmissions, the way human spacecraft do when they travel through space. But there was nothing, no whispers, no bursts, no patterns hidden in the static. Just silence. At first glance, this silence is exactly what we should expect. Comets, after all, do not talk. They are balls of ice and dust, driven by sunlight, with no reason to emit radio signals. Their only voice is the glow of their tails and the chemistry they release. In that sense, 3i Atlas was behaving exactly as nature intended. Its quiet presence matched what physics predicts. And yet silence can sometimes be louder than sound, especially in the context of interstellar visitors. When Oumuamua passed by in 2017, scientists from the Breakthrough Listen project pointed some of the most powerful radio telescopes in the world toward it, just in case. They detected nothing. When 3i Atlas arrived, the same approach was taken, and once again, the result was silence. For scientists, this is data, evidence that neither object carried an active transmitter. But for others, it invites a more unsettling question. What if the silence is intentional? Imagine you are walking through a dark forest at night. You hear no birds, no insects, no rustle of leaves. The silence itself feels unnatural, as though something is there, watching, choosing not to make a sound. This is the essence of the dark forest hypothesis, the idea that advanced civilizations might remain silent, avoiding detection to protect themselves from predators. If that is true, then a disguised probe like 3I Atlas would not broadcast its presence. It would move quietly, blending in with natural objects, whispering nothing. Its silence would be its camouflage. This is not just science fiction. Humans do the same. Submarines operate under silent running, turning off non-essential systems to avoid detection by sonar. Military aircraft reduce radio chatter to stay hidden from enemies. Even spacecraft have quiet phases, coasting without sending signals to conserve energy or reduce interference. To assume that an advanced machine drifting across the galaxy would blare radio signals is to assume it wants to be found. What if it doesn't? Another possibility is that we are listening in the wrong way. Radio is our language, not necessarily the universe's. Perhaps 3I Atlas does emit something, but not in a spectrum we know how to interpret. Imagine trying to hear a conversation by staring at the ocean. You'd never detect the sound. Or picture trying to tune into a cell phone call with an old AM radio. The signal might be there, but invisible to the wrong instruments. Could 3I Atlas be speaking in forms of energy we have yet to discover? Even within human history, signals are often mistaken for noise. When pulsars were first discovered, their rhythmic radio beats baffled scientists. They were so precise that some briefly considered them alien in origin. Only later did we understand their nature. Could something similar be happening with 3I Atlas? Maybe its silence is not silence at all, but a signal hidden in patterns we dismiss as random. Brightness shifts, dust trails, faint flickers. What if we simply don't know how to listen? There is also a more chilling thought. What if the silence is a test? Imagine that 3I Atlas was not meant to communicate, but to observe, to drift past us, recording, measuring, and leaving without revealing anything. A probe with such a purpose would not announce itself. Its silence would be deliberate, not a failure of technology, but a feature of design. Just as a spy does not wave a flag, a silent probe would pass without a sound, leaving us only to wonder. And yet, the silence was not meaningless. It reminded us of our own assumptions. We expect the universe to shout when it speaks. We expect signals to be clear, patterns to be obvious. But what if the cosmos is subtler? What if the messages, whether natural or artificial, are hidden in quiet, in rhythms we have not yet learned to translate? 3I Atlas may not have carried a transmitter, but it carried a silence that spoke volumes. In the end, the absence of signals is as much a presence as noise would have been. It forces us to ask, is the universe truly quiet, or are we simply deaf to its language? Was 3I Atlas a comet that never had a voice, or was it something that chose not to speak? And if it chose silence, then perhaps that decision says more about its purpose than any transmission ever could. The Watcher's Dilemma, NASA's careful choice of words, balancing caution and reassurance. When 3I Atlas appeared on our radar, NASA was quick to acknowledge it. Press releases were drafted, scientists gave interviews, and observatories worldwide were encouraged to track it. The tone, however, was telling. Instead of excitement mixed with alarm, the agency spoke with calm precision. An interstellar comet, they said, passing through our solar system. No threat to Earth. The words were measured, chosen carefully, not just to describe, but to manage perception. NASA has long understood that space is not just science, but psychology. When people hear about objects from beyond the stars, their minds leap quickly to fear or fantasy. Headlines cry, "Alien visitor," before the first data is even processed. Social media spins theories of invasion, cover-ups, or cosmic warnings. NASA, aware of this, walks a tightrope. Say too little, and conspiracy theories explode in the vacuum. Say too much, and people imagine dangers that don't exist. The solution is balance, enough detail to reassure, but enough restraint to avoid feeding panic. 3I Atlas was a perfect example. On one hand, it was extraordinary. Only the third interstellar object ever confirmed. Its chemistry was bizarre, its path unrepeatable, its nature mysterious. These facts could have been presented with dramatic flair, but instead NASA emphasized its harmlessness. They stressed that its orbit posed no collision threat. They framed its anomalies as puzzles for scientists, not dangers for the public. Their words were designed not only to inform, but to soothe. Consider how differently it could have been handled. If NASA had highlighted the carbon dioxide dominance, chemistry no comet here displays, without context, it might have fueled suspicion. If they had focused on the timing of its disappearance behind the sun, conspiracy channels would have erupted. Instead, they described it as a unique opportunity to learn, framing its strangeness as discovery rather than danger. This is the watcher's dilemma: how to tell the truth without letting the truth spiral into chaos. We've seen this before. In 1994, when the Shoemaker-Levy 9 comet struck Jupiter in a series of catastrophic impacts, NASA spoke not of cosmic violence, but of a rare natural experiment. When Oumuamua arrived and whispers of alien technology spread, NASA scientists carefully explained possible natural origins: flat fragments, outgassing too faint to detect, while avoiding outright dismissal. They had to leave room for mystery without endorsing fear. 3I Atlas followed in this tradition, and behind this caution is another truth: NASA and agencies like it are watchers for all of us. Their astronomers spend countless nights scanning skies for intruders, asteroids, comets, fragments that could threaten Earth. They know how fragile our planet really is. They know how close some near misses have been. But they also know that constant warnings would erode trust, causing fatigue or panic. So they ration their words, offering reassurance where possible, always aware of the weight those words carry. It's a delicate game of framing. To scientists, 3I Atlas was thrilling because it was rare. To the public, it could sound frightening for the very same reason. To call it an interstellar object sparks awe. To call it alien sparks fear. NASA knows the difference is not in the data, but in the phrasing. They know that words shape imagination, and imagination can ignite like fire. But perhaps there is another layer. Perhaps the carefulness itself invites suspicion. When agencies speak too calmly, too smoothly, people wonder what is left unsaid. Silence can be comforting, or it can be ominous. In the case of 3I Atlas, NASA's restraint was meant to reassure. Yet for some, it was proof that the truth was being hidden, that the object was more than ice and dust. The watcher's dilemma cuts both ways. Speak too little or speak too carefully, and trust begins to fray. So 3I Atlas left us not only with scientific questions, but with human ones. How much should we be told, and how much should be softened? Can the watchers protect us with reassurance without breeding suspicion? And what if someday the truth they have to share is not reassuring at all? As 3I Atlas drifted away, NASA's words remained calm, measured, careful. A voice meant to balance the awe of discovery with the responsibility of trust. It was not just the object that passed through our skies, but also the reminder that every message about the unknown carries weight, that the way we describe the cosmos can shape how humanity faces it. The global net, how observatories worldwide work together to track its fading trace. When 3I Atlas slipped into view, it wasn't just one telescope that noticed. It wasn't the triumph of a single observatory, nor the claim of one nation. It was a chorus of eyes, scattered across continents, rising together in a kind of unspoken coordination. From the dry plateaus of Chile to the mountaintops of Hawaii, from icy peaks in the Canary Islands to vast desert skies in Australia, the global net of observatories began its vigil. Humanity, for a brief moment, was united in watching a faint traveller from another sun. The object was elusive, never a bright spectacle that the naked eye could see, never a blazing comet that drew crowds into fields and backyards. Instead, 3I Atlas was more like a whisper in the static, a faint glow that could so easily be mistaken for noise. To catch it, telescopes had to work together, passing data like lifelines from one hemisphere to another. As the Earth turned, observatories took shifts, handing off the stranger like a relay baton, ensuring it was never entirely lost. There is something profoundly human about this effort. Think of sailors in centuries past, spread across oceans, raising lanterns to signal one another across the waves, or of watchtowers on distant hills, passing fire from peak to peak to warn of an approaching army. 3I Atlas became a similar catalyst, not an enemy, not a storm, but a mystery too precious to lose. Its fading trace demanded vigilance, and the world responded. NASA's own network joined forces with European, Asian, and amateur astronomers alike. In backyards across America, small telescopes, operated not by professionals but by dreamers, added their data to the stream. Some of the most precise measurements came not from the giants, but from modest observatories in quiet towns. It was as if the universe itself had reminded us. Knowledge is not the property of one nation or one institution, but of all who look up. And still, even with the global net stretched tight, 3I Atlas proved slippery. Its tail flickered, its brightness rose and fell without warning, and then, just when interest was at its height, it vanished behind the sun. Observatories that had worked day after day, handing off its faint glow like a secret, were forced to pause. For weeks, nothing could be seen. The net hung empty, waiting for the visitor to emerge on the other side. When it finally reappeared, it was weaker, dimmer, like a voice growing hoarse. Yet the network caught it again, refusing to let the trail fade entirely. For a short while longer, its data was captured. Light curves, spectra, chemistry frozen into pixels. Then, as all such travelers do, it slipped beyond our reach, too faint for even the most powerful instruments to follow. What makes this global chase remarkable is not only the science it produced, but the symbolism it carried. In a world often divided by borders, politics, and rivalry, here was a reminder that the sky is shared. No one nation can claim ownership of the stars. No single telescope can guard the heavens. It takes a net woven from many threads stretched across the earth to catch even a glimpse of the strangers that pass through. And yet there was also frustration. For all the effort, for all the coordination, the data was incomplete. Pieces of the puzzle remained missing, like pages torn from a book. Scientists could not agree on all the answers. Was its chemistry natural or unusual beyond explanation? Was its flickering tail simply physics, or something stranger? The net had caught the visitor, but only briefly, and its secrets slipped through the weave. Perhaps that is the true lesson of the global net, that the universe will not always yield its mysteries, no matter how many eyes we turn toward it. That even when humanity works together, some things remain just beyond our grasp. But also that in the act of watching, in the shared effort of holding a faint trace against the vast dark, we discover something about ourselves, that we are capable of unity, however fleeting, when the sky demands it. 3I Atlas left us with more questions than answers, but in the wake of its passage, it also left behind a moment of collaboration, an invisible net stretched across the world, catching light from a traveller that may never return. A reminder that though the visitors are fleeting, our shared gaze can be enduring. Older than Earth, evidence that it predates our solar system itself. When 3I Atlas appeared, drifting silently into our skies, scientists realized they were not just looking at an interstellar visitor, they were looking at something older than Earth itself, not by centuries, not by millennia, but by billions of years. Imagine holding in your hand a pebble washed up on the beach, only to learn that it was formed long before the beach, the ocean, or even the land around you existed. That is what 3I Atlas represents, a fragment of history so ancient that it predates the world beneath our feet. Our solar system is about 4.6 billion years old, born when a vast cloud of gas and dust collapsed under its own gravity, igniting the sun and spinning out planets from the leftover debris. But 3I Atlas did not belong to that story. Its hyperbolic orbit, racing outward in a one-time arc, proved it was not tethered to our star. It came from elsewhere, from another system, from another time. That alone makes it extraordinary. But the chemistry revealed something even more astonishing. When the James Webb Space Telescope studied its outgassing, it detected a dominance of carbon dioxide, unlike any comet we know from our own backyard. Most comets here preserved relics of the early solar system, breathe mostly water when heated by sunlight. 3I Atlas, by contrast, exhaled something older, colder, stranger. It suggested that it formed in a star system where conditions were not like ours, perhaps at a distance so great that water never condensed, only carbon dioxide ice. That fingerprint marks it as alien, not just in trajectory, but in birth. And here lies the wonder: if 3I Atlas came from another star, then it also carries the timeline of that star system. It may have been born in the early days of the Milky Way, when stars were young and violent, when collisions between planets and moons scattered fragments like shrapnel across the galaxy. Some of those fragments were flung outward at escape velocity, ejected forever from their homes, set adrift in the interstellar void. 3I Atlas may be one such exile, older than our Earth, older even than our Sun, wandering alone for billions of years until, by chance, it crossed our path. To grasp this, think of family heirlooms, a photograph, a ring, a piece of cloth, objects passed down through generations, carrying with them the touch of lives long gone. 3I Atlas is a cosmic heirloom, not passed down intentionally, but preserved nonetheless. It may carry within its dust the chemical memory of a planet that no longer exists, a star that has already died, a system swallowed by time. Studying it is like examining an artifact pulled from ancient ruins, except these ruins are not on Earth, they are scattered across the galaxy. There is something profoundly humbling in this. We often measure our lives in decades, our civilizations in centuries. Even Earth itself feels eternal to us, its mountains immovable, its oceans timeless. But 3I Atlas reminds us how young we are. Our world is a newcomer in the galactic theatre. Long before there were trees or oceans or continents here, this icy traveller was already moving, already surviving, already carrying secrets in its frozen heart. And yet, the age of 3I Atlas also raises a haunting thought. If it has wandered for billions of years, what has it seen? What has it passed? Did it brush close to other suns, warming briefly before racing outward again? Did it graze the edges of other systems, unnoticed by civilizations that may have risen and fallen in its wake? Could it have drifted past worlds alive with oceans, skies, and watchers of their own? To think of it is to imagine a silent witness, a ghost of time, drifting endlessly through a galaxy that changes around it while it remains the same. Some scientists argue that interstellar objects like 3I Atlas are more than curiosities. They are the raw building blocks of galactic history. Each one carries information about its birthplace, the temperature, the chemistry, the violence of its formation. To collect them, to study them, is to practice a kind of cosmic archaeology. But archaeology usually deals with relics of a few thousand years. Here, we are speaking of billions. 3I Atlas is not just a comet. It is a record older than Earth, older than the seas, older than the continents themselves. And perhaps the most humbling thought is this: 3I Atlas will outlast us. Just as it predates our planet, it will continue its journey long after we are gone. Long after our cities crumble, long after the continents drift, long after the sun itself grows red and swallows Earth, 3I Atlas will still be moving, another ghost in the endless dark. Its life is measured not in human years, but in galactic epochs. When we looked at 3I Atlas, we were not simply watching a comet. We were peering into a mirror of time, seeing something that whispered, "You are young, your world is fragile, your history is brief." And yet, here I am, still drifting, still carrying echoes of places and moments you can barely imagine. In its silence, 3I Atlas reminded us of our place, not as the center of the story, but as newcomers watching the relics of a much older play. Survivor of chaos, how it may have endured collisions, radiation, and endless isolation. 3I Atlas is not just remarkable because it wandered into our skies. It is remarkable because it survived long enough to do so. Think about the journey, billions of years drifting through the most hostile environment imaginable. Space is not a gentle void, but a battlefield. Radiation tears at molecules, stars erupt in violent flares, collisions scatter fragments like shrapnel, and the silence of isolation stretches across ages that dwarf the lifespan of entire civilizations. For 3I Atlas to arrive intact is nothing short of astonishing. Let's start with collisions. The galaxy is vast, but it is not empty. Between the orbits of stars, rogue planets drift unseen. Clouds of dust and debris sweep in spirals. Even other comets wander like invisible arrows. For billions of years, 3I Atlas moved among them. A single impact could have shattered it into fragments too small to detect, leaving no trace. Yet, it survived. Perhaps it was lucky, gliding always just outside danger's reach. Or perhaps it was tougher than we imagine, forged from materials strong enough to withstand blows that would have destroyed a weaker body. Radiation, too, is an enemy. Between stars, the interstellar medium is laced with cosmic rays, high-energy particles born in the violent hearts of supernovae. These are invisible bullets, capable of tearing molecules apart, erasing chemical signatures, and sterilizing whatever they touch. For Earth, our atmosphere and magnetic field shield us. For 3I Atlas, there was no such protection. Its surface, battered for eons, must be scarred and blackened, a crust of survival. Beneath that hardened shell, though, its frozen heart endured. Perhaps it carries chemistry untouched since its birth, a hidden record shielded by layers of cosmic armor. And then there is the greatest challenge of all, time. Not years or centuries, but billions upon billions of years. Time is relentless. Isolation wears down not only objects, but ideas. Imagine walking alone across a desert so wide that no end can be seen, carrying secrets no one will ever ask for. That was 3I Atlas's journey. It was born in violence, perhaps flung outward when planets collided in its home system, or when its star was young and unstable. Since then, it has drifted endlessly, silent, unnoticed, waiting for chance to bring it near another sun. Time itself should have erased it, and yet it persisted. There is an irony here. Fragility is what allowed it to endure. 3I Atlas was not a massive planet or a solid metal rock. It was small, icy, humble, when larger worlds smashed each other to rubble, when massive stars collapsed into black holes, this tiny fragment slipped through the chaos, overlooked, unharmed. Survival, in its case, came not from strength, but from insignificance. The galaxy is filled with titans, but sometimes it is the smallest wanderers that last the longest. And yet, one can't help but wonder, what if its survival was not just luck? What if it was built to endure? If 3i Atlas were not entirely natural, but disguised, then resilience would be essential. It would need to weather impacts, resist radiation, and survive the silence of billions of years. A machine designed to watch, to wait, to travel across epochs would look much like 3i Atlas, rough on the outside, unassuming, but unbreakable within. Its disguise would be its armor. Even if we set aside such speculation, the survival of 3i Atlas offers us perspective. Our Earth is shielded and cared for by a thin atmosphere, yet it struggles under the pressure of centuries. Civilizations rise and fall in the blink of cosmic time. 3i Atlas, meanwhile, has endured storms we can hardly imagine. If it carried a story within it, a chemical memory of its origin, a record of its birth, it would be the story of resilience, a reminder that survival is possible, even in chaos, even in darkness, even in the endless void. To think of 3i Atlas is to picture something both fragile and eternal, an icy shard, scarred and battered, yet still moving, still carrying the whispers of other stars. A survivor, not because it fought, but because it drifted, not because it was mighty, but because it was overlooked. It is both a ghost and a witness, proof that even in a universe defined by violence and loss, something small can endure, and in its survival, it mirrors our own fears and hopes. Humanity, too, faces chaos, climate, war, fragility of systems we think unshakable. We wonder if our story will survive the storms of time. 3i Atlas answers in its silent way. Survival is possible. Not easy, not guaranteed, but possible. Even in collisions, even in radiation, even in isolation, endurance can be written into the very core. That is the legacy of 3i Atlas, not just as a visitor, but as a survivor, a wanderer that endured when the galaxy gave it every reason not to, a fragment of chaos that outlasted chaos itself. The dark forest veil. What if it is a scout, observing silently in a dangerous universe? Imagine standing in a vast forest at night. The trees loom high, shadows stretch in every direction, and the silence is heavy, not peaceful, but tense. You know you are not alone. Somewhere out there, other beings move, unseen. Maybe they are harmless wanderers like you, or maybe they are hunters. In such a forest, to reveal yourself is to risk everything. The safest choice is silence, to move carefully, to observe, to stay hidden. This, in essence, is the dark forest hypothesis, the unsettling idea that the universe might be just like that forest. Applied to 3i Atlas, the thought is chilling. What if it was not just a comet, but a scout, a silent observer passing through, gathering information without revealing itself? Its disguise would be perfect. From a distance, it flared and faded like any other comet. Its chemistry, though strange, could be explained away. Its path carried it close enough to study us, yet not close enough to alarm us. And then, just as questions began to sharpen, it vanished behind the sun, hidden from our instruments. If a scout wanted to watch without being watched, could it have chosen a better path? The silence of 3i Atlas deepens the suspicion. No radio signals, no detectable transmissions, nothing to mark it as artificial. But silence can itself be a strategy. In a universe where predators might listen for signs of life, an intelligent probe would not announce itself. It would blend into the background noise, observing quietly. Just as submarines in our oceans practice silent running, drifting without sound to avoid sonar, An interstellar scout might do the same, moving without a signal, hidden behind the veil of a comet's dusty breath. And there is precedent for this kind of thinking, both in nature and in human history. On Earth, many species rely on camouflage and stealth. The tiger crouches unseen in the grass. The octopus shifts its skin to match the coral. Even humans in times of war send scouts ahead of armies, disguised, silent, watching. If life evolves intelligence across the stars, it may use the same strategies. The dark forest hypothesis argues that survival depends not on reaching out, but on hiding. If so, then 3i Atlas could be an emissary of that logic, a piece of technology wrapped in ice, drifting silently through the forest. Skeptics will point out the obvious. We have no evidence it is anything but natural. The chemistry, while strange, has explanations in astrophysics. The silence, while eerie, is exactly what we would expect from a comet. But the veil of the dark forest is not about evidence. It is about suspicion. It is about acknowledging that in a dangerous universe, what appears natural may be the perfect disguise. And that if other civilizations fear predators as much as we might, they would ensure their scouts are undetectable, except perhaps to those already advanced enough to see them. Consider too the timing. Oumuamua in 2017, Borisov in 2019, 3i Atlas in 2024. 3 interstellar objects, each stranger than the last, discovered only in recent years as our telescopes became sharper. Were they always passing by, unnoticed until now? Or has something changed? Are we only now seeing the edge of a pattern, scouts drifting past, each wrapped in the veil of a comet, each watching in silence? And what would they be watching for? Perhaps for signs of life, our radio transmissions spilling into space, our cities glowing against the night side of Earth. Perhaps for our progress, rockets lifting into orbit, machines roving across Mars, telescopes peering into the dark. A scout would not need to interact. It would only need to observe, to note that on this small blue planet, a young civilization has begun to stir. The dark forest is not a comforting theory. It suggests the universe is not empty because no one is there, but because everyone is hiding, because silence is survival. In such a universe, 3i Atlas's quiet passage feels less like coincidence and more like strategy. A scout moving in plain sight, veiled as a comet, recording us while leaving no trace of itself. And when it left no answers, only questions. Was it truly ice and dust, or something more? Was it just a wanderer or a watcher cloaked in silence? The veil remains, as veils are meant to, hiding whatever truth lies beneath. 3i Atlas is gone, but the thought it carried lingers. In a forest as dark and dangerous as the universe, perhaps the most perfect disguise is the one that keeps you unseen, even when you are right in front of us. Machines that mimic nature. Could alien engineering hide inside a comet's fragile shell? Nature is often the best teacher. When humans design ships, we look to fish. When we build airplanes, we study birds. Even our camouflage borrows from leaves, snow and sand. But what if somewhere out there, another intelligence has taken the same lesson further? What if alien machines were not gleaming metal saucers or towering monoliths, but imitations of the most ordinary objects in the universe, comets, fragile on the outside, but with a purpose hidden within? 3i Atlas invites this very thought. To the telescopes that tracked it, it looked like a comet, a nucleus of ice and dust, flaring as it neared the sun, trailing a faint tail. Yet its behavior was strange enough to unsettle. Its chemistry, dominated by carbon dioxide instead of water, defied what we see in our local comets. Its tail flickered unevenly, like a sputtering signal. Its sudden disappearance behind the sun came at the exact moment curiosity peaked. All of these can be explained by natural processes, but they can also be viewed through another lens, the possibility of mimicry. Imagine if you wanted to send machines across the galaxy. You wouldn't build them to stand out. You wouldn't make them emit obvious signals. You would hide them in what the universe already provides. And comets are perfect candidates. They are everywhere. They are expected. They come and go, rarely studied closely except by specialists. To wrap a machine in an icy shell, let it drift for billions of years, and let it flare naturally when it nears a star, that would be camouflage so effective that even advanced observers might dismiss it as nothing more than another frozen rock. This idea is not as far-fetched as it sounds. Humans have already begun to mimic nature in ways that blur the line between the organic and the artificial. Micro-drones shaped like insects, submarines designed to move like whales, algorithms that model themselves on the branching of trees or the flow of rivers. The principle is the same. To survive and thrive, technology often hides in the shapes nature already perfected. Why wouldn't a civilization capable of interstellar travel follow the same path? Consider, too, the problem of endurance. A metal spacecraft exposed to the harshness of interstellar space for billions of years might erode, crack, or lose functionality. But encase it in ice, dust, and rock, and you gain insulation, protection, and camouflage all at once. The fragile shell, paradoxically, becomes a shield. Radiation scars the surface but leaves the core untouched. Impacts chip the crust but preserve what lies inside. To outside eyes, it looks exactly as it should, a battered comet. Inside, something else could wait, dormant but intact. Of course, skeptics argue that this is simply imagination running ahead of evidence, and they are right to be cautious. 3I Atlas, as far as we know, is a natural object. Its carbon dioxide dominance may be the result of formation in a colder star system, nothing more. Its flickering may be irregular jets of gas, its disappearance behind the sun mere bad timing. But the possibility lingers because it feels so plausible. If we, as a young civilization, can imagine using comets as disguises, then surely an older, wiser one might have done it already. Think of it this way. If you saw a snowball lying in the yard, you wouldn't expect it to contain a machine. You would assume it was just snow, and 9 times out of 10, you'd be right. But what if, just once, the snowball had a clock inside it? Would you ever know unless you broke it open? The universe is filled with snowballs, icy comets drifting endlessly. We only study a handful in detail. Could one of them carry a secret? 3I Atlas was too distant, too fast, and too brief to probe directly. We could only watch as it passed, cataloguing its quirks, speculating about its origin. But its very existence reminds us of how easy it would be to miss what lies beneath the surface. If an alien machine did hide inside such a shell, we might never notice. We would record its orbit, study its chemistry, marvel at its strangeness, and then let it slip away, its secret intact, its mission unbroken. Machines that mimic nature are not new to us, but when we extend the idea to the cosmos, they become more than clever tricks. They become strategies for survival in a universe where silence may mean safety and disguise may mean endurance. 3I Atlas, natural or not, showed us how perfect such a disguise could be. Fragile on the outside, unremarkable to the eye, and yet perhaps carrying something hidden within. And whether or not it truly was, the thought lingers long after the comet has gone. Because the next interstellar visitor may arrive tomorrow or in 100 years, and when it does, we will look at it differently. We will wonder, not just what it is, but what it might be hiding. The fear of contamination. Why scientists debate whether studying it up close would be safe. When 3I Atlas passed through our solar system, the temptation was obvious. What if we could send a probe to meet it, to gather samples, to look directly at what it carried? After all, comets are often described as time capsules, frozen relics of their birth systems, preserving chemistry untouched for billions of years. To study 3I Atlas up close would be to hold in our hands a fragment of another star. And yet, even as scientists dreamed of such a mission, a darker question hovered. Would it be safe? The fear of contamination runs both ways. On one side lies the risk to us. What if the comet carried not just dust and ice, but microbes, alien organisms preserved in its frozen core, dormant but viable? Panspermia, the theory that life can spread between star systems on the backs of comets, has been discussed seriously for decades. If true, then 3I Atlas could be more than inert matter. It could be a carrier of life or of something deadly. Imagine opening a sealed container that had been locked for billions of years, only to find it teeming with organisms adapted to survive extremes far harsher than Earth. Would we unleash something we cannot control? The other side of the fear lies in protecting it from us. When the Rosetta spacecraft landed its probe, Philae, on Comet 67P, great care was taken to sterilize instruments. Even so, some worried about contamination from Earth microbes hitching a ride. With an interstellar object, the stakes would be even higher. If 3I Atlas carried pristine chemistry from its birth system, a single Earth germ could muddy the evidence forever. It would be like spilling ink across an ancient manuscript before you had the chance to read it. For some, the danger feels exaggerated. After all, the chances of viable life surviving billions of years in the vacuum of interstellar space seem slim. Radiation alone should shred DNA, break apart proteins, erase fragile molecules, and yet Earth teaches us caution. Bacteria have been found alive after being trapped in salt crystals for millions of years. Tardigrades, tiny, near-invisible creatures, can survive the vacuum of space for years, reviving when water returns. Life, once it appears, is far more stubborn than we expect. So, when faced with something as ancient and alien as 3I Atlas, can we really dismiss the possibility entirely? The debate over contamination is not new. When the Apollo astronauts returned from the moon, they were quarantined for weeks, just in case lunar dust carried unknown pathogens. In the future, samples from Mars will be brought to Earth under the strictest of biosafety controls, sealed inside facilities designed to contain even the most improbable risks. An interstellar comet would demand even more care, not only because of what it might hold, but because of what it represents. Material not just foreign to Earth, but foreign to the Sun itself. And then, there is the more unsettling possibility. What if contamination is not accidental? What if, in the darkest interpretation, 3I Atlas was designed to carry something? Imagine a machine disguised as a comet, releasing spores as it passes through new star systems. Or nanotechnology hidden in ice, waiting for warmth to awaken it. Far-fetched, perhaps. But the thought lingers because the disguise is so perfect. Who would ever question a comet shedding dust and gas? Who would see it as a delivery system until it was too late? Even setting aside such conspiratorial fears, scientists wrestle with the practical truth. Up-close study is both irresistible and risky. To understand 3I Atlas is to risk disturbing it. To bring a sample home is to risk introducing something we cannot predict. To leave it untouched is to let the opportunity slip away, perhaps for centuries. It is the same dilemma faced by archaeologists who uncover a sealed tomb, or biologists who stumble upon a hidden ecosystem. Do you open the door, knowing that what lies inside could rewrite history or could endanger everything? In the end, 3I Atlas escaped such decisions. It moved too fast, too briefly for us to send a mission. We were left only to observe from afar, safe but unsatisfied. but its passing reignited the debate, a quiet reminder that one day we will face this choice. Another interstellar visitor will arrive, and perhaps this time we will be ready to meet it. When that day comes, the fear of contamination will be more than theoretical. It will be a question of survival, of trust, of how much risk we are willing to take for knowledge. 3i Atlas slipped away, leaving us with no danger, no contamination, only the haunting thought of what might have been hidden within. And in that silence, the debate continues. Are the secrets of interstellar travelers worth the risks of opening them? Or is the greatest danger not what they carry, but our own hunger to look inside? Myths of messengers. How ancient cultures might have interpreted such a visitor. Long before telescopes mapped the heavens with precision, human eyes searched the night sky for meaning. Stars were not just distant fires, they were gods, guardians, and storytellers. Comets, especially, stirred deep emotions, arriving suddenly, burning brightly, and vanishing as mysteriously as they came. To ancient cultures, these ghostly wanderers were never ordinary. They were omens, messengers, sometimes blessings, sometimes curses. If 3i Atlas had appeared 1,000 or 5,000 years ago, it is almost certain it would have been folded into myth and legend. Consider the Babylonians, whose priests tracked celestial movements on clay tablets. To them, the skies were a divine clock, and anything unexpected was a warning. A faint star-like speck growing into a glowing apparition would not have been viewed as a natural traveller, but as a message from Marduk or Ishtar, an omen of war, famine, or the rise of a new king. The record keepers would have etched 3i Atlas's glow into their tablets, noting its path as a sign that heaven itself had spoken. In China, comets were described as broom stars sweeping across the sky. Their sudden appearance was linked to political change, the fall of dynasties, or the anger of ancestors. A visitor like 3i Atlas, so faint at first, yet growing brighter before disappearing behind the sun, might have been read as a subtle message, something stirring in the realm of spirits, invisible but watchful. The emperor's astrologers would have debated its meaning, warning of betrayals or upheaval. Among the Mayans, who built their calendars upon the cycles of celestial bodies, such an object might have been seen as a herald of cosmic renewal. To them, the heavens were alive with patterns that echoed down to earth. A new and mysterious light would not just be a sign, but a participant in the cosmic drama. Rituals would be performed, offerings made, not to fear the visitor, but to fold it into the great rhythm of time. And in medieval Europe, where the sight of a comet could strike terror into peasants and kings alike, 3i Atlas might have been remembered as a harbinger of plague or divine punishment. Chroniclers could have described it as a fiery cross or an angel's torch sent to light the world in warning. Just as Halley's Comet was linked to the Battle of Hastings in 1066, this interstellar traveller could have been tied to any earthly calamity or triumph occurring nearby. The fascinating thing about myths is that they rarely focus on what an object is, but on what it means. To ancient eyes, the details we now parse scientifically, its hyperbolic orbit, its strange chemistry, its speed, would not have mattered. What mattered was its story, and in every culture, that story was woven into human hopes and fears. Comets carried messages not because they chose to, but because people needed them to. They were screens onto which humanity projected its deepest anxieties and desires. Imagine a world lit only by fire, with no satellites, no city glow, only the stars overhead. On such nights, 3i Atlas would have appeared as a subtle glow, a streak cutting across the familiar constellations. Villagers might have gathered in silence, elders whispering of omens, children clutching charms for protection. For them, the visitor was not a lump of frozen gas from another star system. It was a messenger, perhaps the voice of God's too distant to speak plainly. Even today, though science has replaced myth in explaining such objects, the old instinct remains. We speak of Three-Eye Atlas as if it had intent, as if it chose its path or carried secrets. We wonder if it is natural or artificial, if it hides a message, if it watches us. The language of myth persists, dressed now in scientific vocabulary. Perhaps this is inevitable. The skies are too vast, too mysterious to be stripped of story. If ancient cultures had witnessed Three-Eye Atlas, they would have remembered it in song and scripture. They would have carved it into stone, painted it onto walls, told children that it was a messenger from beyond. And maybe, in their way, they would not have been wrong. For even if it was only ice and dust, carried here by the silent drift of the galaxy, it still bore a message. That we are not alone in our skies, that the universe is larger and older than we can fathom, and that sometimes visitors come unannounced, slipping into our world like whispers from the gods. The disguise of dust. Why comets are perfect camouflage for probes drifting between stars. If you wanted to travel across the galaxy unseen, what form would you choose? Would you send a gleaming ship of steel, radiating energy and betraying your presence to every telescope that glanced your way? Or would you take on a shape so ordinary, so expected, that no one would ever question it? In a universe filled with countless drifting comets, there may be no disguise more perfect than dust and ice. Three-Eye Atlas, with its faint glow and fading plume, embodies this idea. At first glance, it was nothing unusual, just another icy wanderer passing through the solar system. Its orbit was strange, yes, its chemistry puzzling, but comets have always been tricksters, defying neat explanations. If someone, or something, wanted to hide a probe, wrapping it in a comet's shell would be a masterstroke of camouflage. It would blend seamlessly into the cosmic background, moving in plain sight while revealing nothing of its true purpose. Dust is, in many ways, the universe's great concealer. It softens the brightness of stars, hides the cradles where planets are born, and cloaks galaxies in veils of shadow. A comet's dust works the same way, trailing behind it in chaotic patterns, reflecting sunlight, but obscuring the core within. To human telescopes, Three-Eye Atlas was little more than a shifting glow, its true nucleus hidden beneath layers of particles. If an artificial machine were inside, we would never have seen it. The idea sounds fantastical, yet it echoes what humans already do. Military aircraft use radar-absorbing coatings to mask their presence. Submarines run quiet to blend into the ocean's noise. Even our spacecraft carry shields to protect delicate instruments, disguising what lies beneath. Nature itself perfected the art of camouflage long before us. Moths with wing patterns like tree bark, fish shimmering like sunlight on water, owls so still they vanish into the branches. To mimic a comet is to take camouflage to the grandest scale imaginable. And there are practical advantages too. An icy shell offers protection. Radiation, which can fry electronics in deep space, would be absorbed by layers of frozen carbon dioxide or water ice. Impacts with micrometeoroids would chip at the crust, but leave the interior intact. The dust itself could serve as both insulation and decoy, masking any heat signatures or emissions that might otherwise betray an artificial core. In effect, the comet would serve as both armor and cloak. Some theorists even imagine a deeper cleverness. What if the outgassing of a comet, the jets of gas and dust that flare as sunlight warms it, could be harnessed as propulsion? A natural system driven by physics alone, pushing a hidden probe forward while making its movement seem entirely organic. To outside eyes, the irregular flickering of Three-Eye Atlas's tail was just cometary behavior. But what if it was controlled, at least in part, to guide its trajectory while maintaining the illusion of randomness? Skeptics rightly point out that no evidence supports this. Every quirk of 3I Atlas can be explained by natural astrophysics, its odd chemistry by its birth in a colder system, its hyperbolic orbit by gravitational slingshots, its vanishing act by the geometry of its path around the sun. But the brilliance of camouflage is that it invites no suspicion. That is the entire point. If a machine hides inside a comet, we are not supposed to notice. Imagine it this way. If you placed a diamond inside a lump of coal, who would ever look closely enough to find it? The lump would burn, flake, and crumble, and observers would dismiss it as ordinary. Only by breaking it open, only by reaching inside, could you discover what it really contained. Interstellar comets are like lumps of cosmic coal drifting past us, ordinary to all appearances, yet perhaps just once, holding something extraordinary within. 3I Atlas was too distant, too swift for us to break open. We watched it glow faintly, puzzled over its chemistry, and let it drift back into the void. But its passage leaves us with an unsettling thought. If comets are perfect disguises, how many have already passed us by unseen? How many probes, cloaked in dust, have slipped silently through our skies, their secrets safe beneath fragile shells? Perhaps the true brilliance of the disguise lies not in the dust itself, but in our willingness to accept it. We see a comet and we think we know what it is. That assumption may be the camouflage's greatest strength, for in the dark forest of the galaxy, the safest place to hide may not be in the shadows at all, but in the spotlight, appearing so ordinary that no one ever thinks to look twice. The great filter question. If civilizations vanish, could their relics continue to travel? The universe is ancient beyond comprehension. Stars are born, burn brightly, and die. Planets rise from dust, oceans form, life stirs, civilizations awaken, and then often they fall silent. Against this backdrop, astronomers and philosophers wrestle with the great filter, the haunting idea that somewhere along the path from simple organisms to star-faring cultures, there is a barrier few ever cross. Perhaps it is the leap to intelligence. Perhaps it is the survival of technology without self-destruction. Perhaps it is something we cannot yet imagine. But if civilizations vanish, as the theory suggests, what becomes of the relics they leave behind? This question casts 3I Atlas in a strange and almost mournful light. What if it was not merely ice and dust, but the debris of a civilization erased long ago? If an advanced species built machines wrapped in cometary shells or used icy bodies as vehicles for exploration, those creations could survive their makers by billions of years. Even if the builders succumbed to war, disease, resource collapse, or cosmic catastrophe, their relics would go on, drifting endlessly between the stars, silent but enduring. Think of Earth's Voyager probes. Launched in the 1970s, they carry golden records etched with our music, our languages, our sounds of life. Long after humanity is gone, long after the continents have shifted and the seas boiled away, those fragile spacecraft may still sail through the galaxy. They are time capsules of a vanished world. If 3I Atlas is natural, it is extraordinary. But if it were artificial, it might be exactly this, a voyager of someone else, from a civilization erased by the great filter, a message in a bottle cast adrift in the interstellar sea. The thought is humbling. Imagine finding an abandoned ship washed ashore on a beach. Its crew is gone, its sails are torn, but its wood still floats. From it, you can piece together fragments of the people who built it, their tools, their journeys, their fate. In the same way, interstellar relics, whether intentional probes or unintentional debris, could serve as cosmic archaeology. They may tell us of technologies that lasted beyond civilizations, surviving where their creators could not. Science fiction has long played with this idea. Ancient derelict vessels drifting between stars, machines left behind by builders who no longer exist, silent monuments waiting to be discovered. But science, too, entertains the possibility. Freeman Dyson once speculated that civilizations might construct massive artifacts, Dyson spheres, stellar engines, that could outlive them. If so, why not smaller machines, disguised as comets, wandering on for ages after their creators disappeared? This makes 3I Atlas both fascinating and unsettling. Its hyperbolic orbit proves it came from beyond the Sun. Its chemistry is strange enough to spark questions. Its timing, arriving only a few years after Oumuamua and Borisov, feels uncanny. If it is natural, it is still a relic, a frozen archive of a star system we will never see, carrying the dust of worlds that may no longer exist. But if it is artificial, then it is something even stranger, the ghost of a civilization that already faced its great filter and lost. The filter itself raises another possibility. Perhaps the galaxy is littered with relics precisely because civilizations don't survive long enough to build empires. They reach out once, send a handful of probes, launch a fleet of disguised scouts, and then vanish. What remains are fragments, silent, drifting, carrying evidence of their rise and their fall. We may not meet their makers, but we may stumble upon their echoes. Some thinkers see hope in this. If relics can outlast civilizations, then knowledge too can endure. Perhaps 3I Atlas, if it is a relic, is not a warning but a gift. Proof that intelligence once existed elsewhere. Proof that we are not alone. Others see only dread. If every interstellar visitor is the broken shell of something greater, then the filter awaits us too. Our future may already be written in the silence of the stars. 3I Atlas offered no answers. It came, it flickered, and it left. But the great filter question remains. If civilizations vanish, could their relics continue to travel? And if so, how many are passing us by even now? Silent reminders of those who dreamed, who built, and who ultimately fell, leaving only their machines to wander forever. The needle in the cosmos, how rare such detections are, and why rarity fuels paranoia. Finding an interstellar visitor like 3I Atlas is like stumbling upon a single drifting feather in the middle of the ocean. The cosmos is vast beyond measure, filled with countless icy wanderers, yet the odds of one passing close enough for us to notice are staggeringly small. For most of human history, we had no idea such objects even existed. Our telescopes weren't sharp enough, our surveys not constant enough. The night sky looked eternal and unchanging. Then suddenly, within just a few short years, 3 interstellar travelers revealed themselves. Oumuamua in 2017, Borisov in 2019, and 3I Atlas in 2024. 3 needles found in the cosmic haystack. The rarity of these detections raises an obvious question. Were they always here, slipping past unseen, or are we now witnessing something unusual? The human mind is quick to make patterns out of coincidence. When a once-in-a-lifetime event happens 3 times in a decade, it feels less like chance and more like a shift, like a secret door has opened. Scientists explain the discoveries as a result of better instruments, telescopes that sweep wider and deeper than ever before. And they are right, but rarity has a way of amplifying suspicion, especially when what we find looks so strange. Oumuamua's cigar-like shape and bizarre acceleration. Borisov's almost textbook cometary behavior, yet with chemistry not quite like homegrown comets. 3I Atlas's dominance of carbon dioxide, its odd fading and flaring tail, each one different, each one not fitting comfortably into the categories we know. Imagine if you walked into a forest and found not one, but 3 animals you had never seen before. each resembling something familiar, yet just different enough to unsettle. Would you believe you'd seen nature's quirks, or would you start to wonder if you were being watched? That's where paranoia seeps in. The fewer examples we have, the harder it is to build certainty. With only 3 confirmed interstellar visitors, every anomaly looms large. If we had found hundreds, strange chemistry or odd paths would blend into the averages. But with so few, each peculiarity feels like a clue or a warning. Scientists tread carefully, parsing what is natural and what might be extraordinary. Conspiracy theorists, however, leap into the gaps, weaving stories of hidden probes, alien scouts, or even deliberate visits disguised as comets. Rarity is fertile soil for imagination. Consider how people once reacted to eclipses. They happened infrequently enough that each event seemed supernatural, a disruption of the natural order. Today we predict them down to the minute, and the fear has gone. Interstellar visitors may be the same. One day, when telescopes like the Vera C. Rubin Observatory begin scanning the skies every night, we may catalogue dozens, maybe hundreds, of these wanderers. The paranoia will fade. But for now, with so few in our record books, each one feels like an omen. And perhaps that feeling isn't entirely wrong. Even if 3i Atlas is perfectly natural, its rarity carries meaning. It reminds us how limited our vision still is, how much of the galaxy passes by unseen. For every one object we detect, countless others drift silently, never crossing our telescope's gaze. The rarity forces us to consider what we're missing, and whether something among them is not what it seems. Think of it like messages in a bottle. If you found one bottle on the shore, you'd be amazed. If you found 2, you might call it coincidence. But if you found 3 in quick succession, you'd wonder, is someone out there sending them on purpose? With Oumuamua, Borisov, and 3i Atlas, humanity stands on just such a shore, looking at bottles that may hold nothing but seawater, or may carry something written long before we were here to read it. 3i Atlas was rare, perhaps only one of millions to pass near Earth, yet it was seen, tracked, puzzled over. Its rarity does not only fuel paranoia, it fuels imagination. And in a universe as vast as ours, imagination may be the first step toward discovery. Beyond Voyager's reach, why no probe could ever have intercepted 3i Atlas in time? When 3i Atlas appeared on astronomers' screens, it was already too late. The faint glow that betrayed its presence in our skies came only after it had entered the inner solar system, already racing on a path that would carry it back into interstellar darkness. By the time humanity knew it existed, the visitor was moving at a speed far beyond anything we could hope to match. It was like seeing the tail lights of a car vanish down a highway when you are still searching for your keys. Our fastest spacecraft, Voyager 1 and Voyager 2, have been travelling outward since the 1970s. They have left the solar system, true pioneers of human engineering, carrying golden records meant to represent our species to whoever might one day find them. Yet, despite nearly 50 years of travel, Voyager 1 moves at about 38,000 miles per hour. 3i Atlas sped through the solar system at well over 60,000 miles per hour, and more importantly, it was already here and leaving before we even noticed. Catching up would have required not just speed, but timing. To intercept such an object, you need to launch a probe almost immediately after detection. But launches take months, even years of preparation. Rockets must be assembled, instruments tested, trajectories plotted. By the time 3i Atlas was confirmed as interstellar, it was already beyond reach. Imagine trying to throw a message in a bottle into the ocean to catch another bottle drifting past at full speed. It's a race you cannot win without preparation long before the encounter. This is one of the most frustrating truths of interstellar discoveries. They come unannounced, fleeting, and fast. Oumuamua zipped past Earth within weeks of discovery. Borisov gave us more time, but even then, no probe could be redirected quickly enough. 3i Atlas followed the same cruel pattern, a whisper of light appearing in the telescope, then a blur, then gone. Our technology lags behind our curiosity. We are watchers only, unable to chase. And this is where the sense of helplessness creeps in. Humanity dreams of exploration, of reaching out and touching the stars. But in moments like these, we are reminded how small our reach truly is. Our probes are like rowboats on a shore, while interstellar visitors are great ships passing by, their sails already filled with winds we cannot catch. Even New Horizons, the spacecraft that flew past Pluto and ventured into the Kuiper Belt, is far too slow and on the wrong trajectory to even dream of pursuing 3i Atlas. Yet the thought lingers, what if? What if we had been ready? Engineers have imagined rapid response missions, spacecraft on standby, waiting for just such an event. Concepts exist on paper, probes that could launch within months, accelerated by powerful rockets or even solar sails, racing to meet the visitor before it slips away. But paper is not the same as reality. The infrastructure, the funding, the political will, they are not yet in place. So we watched 3i Atlas vanish, and we wondered what secrets it carried. The irony is striking. We send messages like Voyager's golden records into the void, hoping one day another civilization might find them. But when an object drifts into our own backyard, perhaps natural, perhaps not, we are powerless to reach it. It's as if two bottles drift past each other in the ocean, their messages never read, their stories never shared. Some scientists argue that this is how it will always be. The distances are too great, the speeds too high. Others insist that the challenge is exactly what will drive us forward. The knowledge that we missed 3i Atlas, that it came and went without us touching it, may fuel the determination to be ready for the next. For now, though, the truth is sobering. Voyager sails on, carrying our voice into the stars. 3i Atlas sped past, carrying who knows what, from another system. The two never met, and we were left only to imagine the encounter that never happened. It is a reminder that while we long to join the dialogue of the galaxy, we are still children at the edge of the playground, watching others pass by, unable yet to take part. 3i Atlas is gone. Voyager still goes. But the space between them, the unreachable gap, is where our imagination lingers. The conspiracy of silence. What some believe NASA and governments might be hiding. Whenever a mystery appears in the night sky, two stories unfold at once. One is scientific, the measured reports of telescopes, data tables, chemical analyses, sober words of caution. The other is whispered, the suspicion that not everything is being told, that behind the official language there are secrets tucked away, known only to governments and agencies. 3i Atlas, with its faint glow and peculiar behavior, has inspired both. For many, the silence of 3i Atlas seemed too convenient. It arrived, puzzled astronomers with its strange chemistry, disappeared behind the sun, and then slipped away before we could study it in detail. NASA's official updates spoke carefully, an interstellar comet, unusual in its composition, but nothing dangerous. Yet conspiracy thinkers heard something else in that tone. Too careful, too calm. They asked, why emphasize safety unless there was something unsafe to hide? This suspicion is not new. Since the Roswell incident in 1947, public trust has been colored by the belief that governments might conceal encounters with the extraordinary. UFO reports filed by military pilots, declassified documents with heavy blacked-out lines, unexplained aerial phenomena. Each one feeds the idea that what we are told is only the surface, while deeper truths remain hidden. Against this backdrop, 3-Eye Atlas fit neatly into the narrative. If it was just ice and dust, why the cautious phrasing? Why not more transparency? Some conspiracies go further. They suggest that 3-Eye Atlas was not merely a comet, but a probe, and that NASA knew it, or at least suspected it, but withheld the information to avoid panic. After all, what would happen if an official press release stated, "We don't know what it is. It could be natural, or it could be artificial"? The reaction might spiral from awe to fear in an instant. A public already steeped in apocalyptic media and distrust of institutions might imagine invasion fleets following close behind. For stability's sake, the argument goes, silence was safer. And then there is the question of detection itself. Telescopes spotted 3-Eye Atlas only after it was already well within the solar system. What if governments had earlier warning, classified sensors perhaps, designed to track objects in deep space? Some claim the military has such capabilities, capable of seeing far beyond what civilian telescopes reveal. If that were true, then perhaps officials had known for months, quietly gathering information before announcing the discovery to the public. Of course, skeptics point out that these suspicions are fueled by gaps in knowledge rather than evidence. NASA does release data. Observatories around the world, many not connected to any government, confirmed 3-Eye Atlas's presence and behavior. Science thrives on open sharing. It would be almost impossible to suppress observations made across so many countries. And yet, the very openness of the scientific community can make official language sound restrained. Scientists do not leap to conclusions. They hedge, they couch, they use words like unusual and uncertain. To the public ear, that can sound like avoidance. It's worth remembering that silence itself can be powerful. When questions outpace answers, the absence of information feels like evidence. If you hear a locked door in a house you're told is empty, you start to wonder what's inside. In the same way, when 3-Eye Atlas passed and no bold explanation was offered, imaginations filled the void. Was it carrying microbes? Was it a machine disguised in dust? Was it sending signals too subtle for us to catch? Or was it simply ice and rock, extraordinary only in that it came from another star? The conspiracy of silence, then, may not lie in governments withholding the truth, but in the gap between what we long to know and what science can honestly say. Still, for those inclined to doubt, 3-Eye Atlas will remain suspicious. Its faint trail, its vanishing act, its chemistry that doesn't quite fit, all combine into a story that feels incomplete. And when stories feel incomplete, silence itself becomes suspect. What passed through our skies may have been only a natural wanderer, but for some, the unanswered questions linger louder than the data. 3-Eye Atlas is gone, yet the suspicion remains, not just of what it was, but of what we were told, or not told, while it was here. The fragile mirror. How 3-Eye Atlas reflects both our curiosity and our fear. When 3-Eye Atlas first appeared as a faint smudge of light against the starry backdrop, astronomers rushed to study it, not just because it was rare, but because it seemed to whisper something about us. Every interstellar object is a kind of mirror, not one of glass or polished metal, but of meaning. What we see in it depends as much on who we are as on what it is. And in 3-Eye Atlas, humanity saw two things at once: unshakable curiosity and a thread of fear. Curiosity has always pulled us toward the unknown. We build telescopes to peer across the cosmos. We launch probes beyond the edge of the sun's influence. We imagine standing on worlds no human has yet touched. To us, an interstellar visitor is not just a frozen relic, but an invitation. What chemistry does it carry? What history is written in its dust? Could its ices hold the fingerprints of a star system older than our own? When scientists described 3-Eye Atlas's bizarre carbon dioxide dominance, it wasn't just a chemical anomaly. It was a riddle to be solved, a chance to expand the edges of knowledge. But fear lingered too, because the same traits that sparked fascination also unsettled us. Its speed was so great that no probe could ever catch it. Its path was hyperbolic, proving it would never return. Its tail flickered strangely, as if sending messages we couldn't read, and it vanished behind the sun just when attention was at its peak, as though slipping deliberately out of view. Each fact, explained in the language of physics, also carried the flavor of mystery, even suspicion. This duality is not new. When comets blazed across ancient skies, people saw both beauty and danger. They were described as heavenly swords, harbingers of change, or gifts from the gods. The same streak of light could inspire awe in one culture and terror in another. Today, we frame our interpretations in science, but the emotional undercurrent is the same. We want to know what Three-Eye Atlas is, and we are afraid of what it might mean. Perhaps that is why the idea of disguise lingers so strongly. To imagine Three-Eye Atlas as a machine hidden inside ice, or as a probe veiled in dust, is to project our fears of being watched, of being small, of being unprepared. At the same time, those very speculations reveal our creativity, our willingness to wonder if we are not alone. The comet, natural or not, became a fragile mirror reflecting both instincts, our eagerness to learn and our instinct to protect ourselves. Even its fragility has symbolism. Comets are not solid fortresses, they are crumbly, volatile, fleeting. They flare brilliantly and then vanish into the dark, sometimes breaking apart entirely. In this way, Three-Eye Atlas mirrored us more than we realized. Our civilizations, too, feel both enduring and fragile, capable of building telescopes that see across galaxies, yet vulnerable to our own conflicts, to disease, to the limits of time. Just as Three-Eye Atlas carries the scars of collisions and radiation, we carry the scars of history. Both of us are survivors, wandering in the spaces between certainty and oblivion. And maybe that is why the sight of such an object unsettles us so deeply. It reminds us that we are not the center of the story, only a chapter in a far greater book. It tells us that the galaxy is restless, filled with wanderers that come and go, some older than Earth itself. Three-Eye Atlas did not arrive to answer our questions. It arrived to provoke them. So when we speak of Three-Eye Atlas, we are also speaking of ourselves. Our curiosity is reflected in the instruments we build to study it. Our fear is reflected in the stories we whisper about what it might be hiding. Together, those reflections form a fragile mirror, showing us not just an interstellar traveler, but humanity's own restless heart, reaching for answers, yet wary of what we might find. The door. It left open. Why its passage makes us certain others will follow. When Three-Eye Atlas swept through our skies, it did not linger. It came quickly, glowed faintly, then slipped back into the shadows of interstellar space. Its visit was brief, like a stranger brushing past us on a crowded street. Yet, for all its fleeting presence, it left behind something that will not vanish, the certainty that it was not the last. Before 2017, humanity had never knowingly seen an interstellar visitor. Our skies seemed vast, yes, but also strangely isolated, as if all comets and asteroids were born here, children of our own sun. Then came Oumuamua, long and dark, moving too strangely to ignore. Then Borisov, a comet with alien ices blazing bright. Then, a few years later, Three-Eye Atlas, fainter, more mysterious, and perhaps more unsettling than both. 3 visitors in less than a decade. 3 doors creaking open where before we thought there were none. It is as if the universe leaned close to whisper, "You are not alone in the flow of debris, not alone in the drift of dust and ice." If Three-Eye Atlas could come from another system, then others must also be on their way. The galaxy is not empty. It is restless. Each star births its own comets, its own frozen wanderers, and some are inevitably flung into interstellar exile. If one reached us, if three reached us, then the skies are alive with countless more, crossing paths in ways we may never predict. The door that 3i Atlas opened is not just about science, it is about imagination. We now know such objects exist, and that knowledge reshapes how we see the night sky. Every faint streak, every shifting glow becomes a potential messenger from another sun. It is like living on the shore of a vast sea. For centuries, we believed no ships crossed it, that we were marooned on our island. And then, suddenly, driftwood washes up on the sand. It may not be a ship itself, but proof that somewhere storms rage and forests fall. Proof that other shores exist. And if driftwood reaches us, what else might? The thought is both thrilling and haunting. Perhaps the next visitor will be more ordinary, a comet much like our own. Perhaps it will be stranger still, defying chemistry and orbit in ways that make us doubt our own understanding. Or perhaps one day one will not be natural at all. Perhaps one will be disguised, a machine wrapped in ice, a silent scout gliding past. If 3i Atlas taught us anything, it is that we must now consider these possibilities. The door is open, and behind it lies both wonder and unease. NASA and other observatories know this, which is why new projects are already underway to scan the skies more deeply. The Vera C. Rubin Observatory, soon to begin its vast survey of the heavens, is expected to find dozens, even hundreds, of interstellar objects. The idea that 3i Atlas was a rare fluke is already dissolving. We are beginning to understand that our solar system is not sealed. It is a crossroads, a place where wanderers from distant suns sometimes pass. But rarity breeds intensity. Because we have seen so few, each one feels like a revelation. And so 3i Atlas left behind not closure, but an open-ended story. It was not a chapter that ends with a period, but with a comma, an ellipsis stretched across the stars. It left us watching, waiting, knowing that more will come. The door it left open is not just to the sky, but to our own minds. Curiosity now grows sharper. Fear, too, lingers. What if the next one carries microbes? What if the next is a relic of a dead civilization? What if one is not driftwood, but a ship itself? We cannot unsee what we have seen. The question is no longer if, but when. 3i Atlas has gone, vanishing into the dark beyond. Yet the space it left behind feels fuller than before. Not emptier, but more alive, more promising, more uncertain. Because when one door opens, others are sure to follow. And now, humanity stands in the threshold, waiting for the next knock from the stars. The perfect disguise. Could 3i Atlas itself be proof that nature and intention are impossible to tell apart? If you stood in a forest and heard a branch crack in the distance, how would you know what caused it? Was it the wind, an animal moving in the undergrowth, or something watching you, choosing not to reveal itself? In the darkness, sound and intent blur together. You cannot always tell the difference between accident and design. The cosmos too plays by these rules, and in 3i Atlas we may have found the perfect example of how nature and intention can be impossible to tell apart. When astronomers first tracked 3i Atlas, nothing about it screamed artificial. It was faint, slow to brighten, a comet-like body that behaved, mostly the way we expect comets to behave. It shed a tail, it flared when it neared the sun, it moved on a hyperbolic path out of the solar system. All of this fits within the language of physics and chemistry, yet at the edges there were cracks. Its composition was dominated by carbon dioxide, unlike most comets in our solar system. Its tail flickered oddly, as if pulsing, as if uneven in ways our models struggled to explain. Its timing, appearing just years after Oumuamua and Borisov, felt almost staged, almost as though we were meant to notice. Science says these things happen. Chemistry varies depending on where a comet formed. Tails flicker because jets of gas erupt unevenly from beneath the surface. Timing is coincidence amplified by better telescopes. And yet, the suspicion lingers, not because evidence proves it artificial, but because it so effortlessly could be. A probe wrapped in ice would look exactly like this. A disguised machine would choose behaviors that we could dismiss as natural. The most perfect camouflage is not invisibility, it is plausibility. We already mimic nature ourselves. Drones shaped like birds, submarines designed like whales, camouflage nets patterned like leaves. Our best disguises do not erase presence, they erase suspicion. To imagine a civilization far older and more advanced doing the same on a galactic scale is not impossible. For them, comets would be perfect. They are common, expected, unremarkable. They flare when warmed, dim when distant, break apart under stress. Who would ever look at one and think, machine? 3i Atlas forces us to wrestle with this uncomfortable truth. Sometimes nature and intention are indistinguishable. A comet can flare like a signal. A probe can shed dust like a comet. A natural fragment can look engineered, and an engineered machine can look natural. The two masks overlap so seamlessly that no telescope can pull them apart. All we are left with is uncertainty, and in that uncertainty, our imagination blooms. This is why 3i Atlas feels so haunting. It asks a question we cannot answer. Are we looking at a rock or at a disguise? It's like standing in front of an ancient statue whose expression is so lifelike, you wonder if it is truly stone or if someone watches from within. Science tells us not to leap to conclusions, and rightly so, but science also admits its limits, and in those limits lies the perfect hiding place. Perhaps that is the lesson of 3i Atlas. The line between natural and intentional is thinner than we like to believe. When an object drifts in from another star, older than our sun, carrying chemistry unlike our own comets, vanishing before we can study it fully, it does not need to do anything else. Its disguise is complete, not because it hides, but because it blends. In the end, the perfect disguise is not invisibility, but doubt. If you can make observers hesitate, make them wonder, make them unsure whether what they see is ordinary or extraordinary, then you have succeeded. 3i Atlas has done exactly that. It has left us wondering, long after it has gone, whether we witnessed only ice and dust, or a mask so flawless that we will never truly know what lay beneath.